Good morning everyone. Today we'll discuss model number 5 airport design. In that these are the brief structure. One is introduction, what are the objectives of airport design, windrows diagram, runway length, basic elements of a runway geometric design, taxiway planning, airport zones, passenger facility and services, airport marking and lighting, recommended some of questions which is asked in video, outcomes and further readings. So first, introduction. In that orientation, according to international the civil aviations of organization, what we call ICAO, a runway is defined a rectangular area on a land aerodrome prepared for the landing and the takeoff of aircraft. The orientation of the runway is an important consideration in airport planning and design. The current runway orientation maximize the possible use of the runway throughout the year, accounting for a wide variety of wind conditions. FAA and ICAO regulations establish rules about runway orientations and their expected coverage runway locations considerations. FAA mandates identification standards for the airport layout that is meant to assistant pilots to easily recognizing runways. A runway is usually orientated in the direction of prevailing winds. The head wind, that is the wind direction of wind opposite to the directions of landing and takeoff, provides a greater lift on the wings of the aircraft when it is taking off. As such, the aircraft rises above the ground much earlier and in shorter length of runway during the landing. The headwind provides a braking effects and the aircraft comes to a stop in the smaller length of runway. Landing and takeoff operations, if done along the wind directions, would require a longer runway. The challenge for the designer is to accommodate all of the aircraft using the facility in a reliable and reasonable manner. In the navigations, all measurements of directions is performed by using the number of compass. A compass is a 360-degree circle. When 0 to 360 degree is north, 90 degrees east, 180 degrees south, and 270 degree in west. You can see the next, you can see this figure, it is clearly given here, north, south, east, west diagram. It's full 0 to 360 degree. So you can see here. See objectives: design and plan airport layout, design facilities whatever the required for runway, taxiway, and the important knowledge about the visual aids. So very important example point of view, windrows diagrams. Many times they will ask with you, explain briefly with the sketch or explain briefly the windrows diagram, the concept of windrow diagram. See, runway orientation using windrows. So orientation is done by using this windrows diagram. The wind data is that is directions, durations and intensity are graphically represented by a diagram called windrows. The plotting of the windrows diagram can be done in the following two ways. Type 1, showing directions and duration of wind. Type 2, showing directions, duration and intensity of wind. Crosswind component. It is not possible to get the directions of opposite wind parallel to the center line of the runway length every day or throughout the year. If the direction of a wind is at an angle to the runway center lines, its component along the directions of the runway will the V cause, and that normally to the runway center line will be the V sign, where V is the wind velocity. The normal components of the wind is called crosswind components. Crosswind components should not exceed 25 km per hour for mixed traffic. So wind coverage, the percentage of time in the year during which crosswind components remains within the limits of 25 km per hour is called wind coverage of the runway. According to FAA, the runway handling mixed air traffic should not be so planned that for 95% time in a year. For busy airports, the wind coverage may be increased to 98 percentage to 100 percentage. So you can see here, this is the typical wind data, wind those directions, 6 to 25 kilometers per hour, then 25 to 50 kilometers per hour, 50 to 60 kilometers, 80 kilometers per hour, and the total percentage in each direction. So there are a number of directions. So the type 1, there are two types. Type 1 windrows, you can see the type 1 windrows diagram. You can showing the directions and durations of wind. You can see in the below picture. So in the type 1 windrows diagram, the radial lines indicates the wind directions, and each circle represent the duration of wind to a certain scale. The total percentage of wind blowing in each directions are plotted and then joined by the straight lines. The best directions of runway indicate along the directions of the longest line on the window rows diagram. So this is the type 1